Hello everyone. In this video we're going to integrate 1 over e to the power x plus 1. So I'm going to be presenting two methods for this integral. Let's go ahead and take a look. So now we have the first method involves the u substitution. So I'm going to call this expression u. So I have u equals e to the power x plus 1. And my goal is to evaluate dx. But I don't have x by itself. So let's go ahead and get the x by itself. From here, I'm going to isolate e to the power x and then ln both sides. Ln e to the power x equals ln u minus 1. And this is going to give me, as you know, ln e to the power x is equal to x. X equals ln u minus 1. And to find dx, I need to differentiate both sides. And that's going to give me 1 over u minus 1 du. So this is going to be my dx. And this is going to be my u. Okay. See what happens when we replace dx with that and e to the power x plus 1 with u. Okay, so this is going to give us 1 over u times 1 over u minus 1 du. And we can write this as du over u times u minus 1. Now this integral can be evaluated by partial fractions. So I'm going to separate 1 over u times u minus 1 into two fractions. And if you remember the method, we can just write it like this. And then from here, our goal is to find the values of a and b. When you make a common denominator, you get the following: a times u minus 1 plus b times u. And you should probably know this shortcut. I can replace u with certain values, even though it's undefined when it's a fraction. In this case, it's okay to do that. So I can replace u with 0 on both sides, and that gives me, this term is going to cancel out, and I get negative a equals 1, which means a equals negative 1. And if I replace u with 1, then I get b equals 1 from here. So I got the values of a and b. So my integral can be written as du over u times u minus 1 can be written as negative 1 over u du plus 1 over u minus 1 du. Okay? So let's see if we can integrate these separately, and those are easy integrals because the first one is going to be negative ln absolute value of u, and the second one is going to be ln absolute value of u minus 1 plus c. Okay, let's not forget the integration constant. Now, we're going to go and back substitute. U is equal to e to the power x plus 1. So this gives us negative ln e to the power x plus 1 plus ln e to the power x plus 1 minus 1, which is ln e to the power x. Obviously, this expression can be simplified because e to the power x is always positive, e to the power x plus 1 is always positive. So we can just forget about the absolute value. Ln e to the power x is equal to x. So this gives us x minus ln e to the power x plus 1 plus c. So this is the first method. And let's go ahead and take a look at the second method. Okay. My second method involves something real nice that works with these kinds of integrals. So my original problem integral was dx over e to the power x plus 1. So I'm going to multiply the numerator and the denominator of this integral by e to the power negative x. And let's see what happens after that. When I multiply e to the power x by e to the power negative x, it's going to become e to the power 0, which is 1. And 1 will become e to the power negative x. And then I'm going to use u substitution again. Did I say e substitution? And here's how the u substitution works this time. I'm going to call this u. So u becomes 1 plus e to the power negative x. And du is the derivative. So the derivative of 1 is 0. The derivative of e to the power negative x is itself times the derivative of negative x, which is negative 1. In other words, it is negative e to the power negative x. And of course, you have to multiply by dx to get the du. So we don't have that in the numerator, but we have the opposite. So this gives us negative du equals e to the power x, e to the power negative x dx. So I can replace e to the power negative x dx with negative du here. Great. So this gives us the following integral, negative du over u. Obviously, it's much simpler than the first integral that we had to deal with because we had to use partial fractions for that one. And let's see how they're going to be equivalent at the end. So the integral of du over u is going to be ln, absolute value of u, but there's a negative sign, so let's go ahead and consider that, and we get the following result. Okay, now let's go ahead and back substitute the u value. Remember, u was 1 plus e to the power negative x, so our integral is going to give us negative ln the absolute value of 1 plus e to the power negative x. 1 plus e to the power negative x cannot be negative, so you don't really need the absolute value. Let's get rid of that and write the e to the power negative x as 1 over e to the power x. And let's go ahead and simplify this expression. Let's see what that looks like. We can make a common denominator, and that's going to be e to the power x plus 1 over e to the power x, and then we have a plus c. And now we have a quotient, and with the quotient rule, remember, if you have ln a over b, you can write it as ln a minus ln b. So let's go ahead and do that here with the negative sign in the front, because that comes from the integral or the original expression. We get ln e to the power x plus 1 minus ln e to the power x. As you know, that is equal to, this part is equal to x, so this gives us negative of ln e to the power x plus 1 minus x plus c. If you negate everything inside the parentheses or brackets, we get x minus ln e to the power x plus 1 plus c. And this, let's go ahead and compare those two solutions now. We got the same answer, yay. Of course, we were supposed to get the same answer using two different methods, but that is going to be the answer to our integral. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.